Good morning, everybody. My name is Christophe Schyns. I'm working for the Belgian Science Policy Office. And the goal of my talk today is to present you different programs and initiatives funded at national level and focusing on Earth observation. As you know, Belgium, we are a small country, then we don't have a real space agency like in France or in Italy or in Germany, for example. But we have a small department. Then to give you an idea, we are 25 people, then it's not so big. And we are a part of BELSPO, and we manage the Belgian participation in different space research programs. First, for sure, the Belgian contribution to ESA. Belgium is the fifth contributor to ESA, which is good compared to the size of the country. We manage also different bilateral cooperation with France, with cooperation, for example, also with Argentina. We have the Commission programs. I'm sure you heard about it. Horizon 2020, Copernicus, and it was already mentioned. Galileo. Also participation is CMWF, EUMETSAT for climate and meteorology, and with ESO. And we have also a national program, Stereo and CVB. I will come back to that. First, I would like to start with a success story. Then we were involved with France, Italy, Sweden, and the European Commission in the development of the vegetation instruments. The first one was launched in 1998 on board of Spot 4, and the second in 2002 on board of Spot 5. The resolution is low, 1 kilometer. It's an optical instrument with 4 bands really dedicated to vegetation and follow vegetation. But what was really important with this mission is that we had daily coverage of vegetation nearly in all the Earth. That means that every day, when there is no clouds for sure, you have images and you can follow the status of the vegetation. This first initiative was followed by a second one developed by ESA with a strong involvement of Belgium. It was called ProbaV. It was launched in 2013. It's still flying now. And again, the goal was to have a daily coverage of the vegetation. And that means that now from 1998, we have everyday images over the world, and we have really a good archive of vegetation. Yes, to ingest and process all this data, Belgium initiated a Center for Image Processing. The goal then is process, archive, distribute the vegetation and probably images. We deliver data everywhere in the world. We have more than 7,000 users now, and it's really flexible, reliable, and we are also processing other sensors. You have the website there. Another initiative, again in collaboration with ESA, it's the development of an hyperspectral instrument that you can put on an airplane. You have an example of an image here. Hyperspectral means 300 bands. Then we go really in the detail, and you see that the spectral range is also really wide. This sensor is operational since 2011. You have the website, and you have also access to the data archive on ESA portal. Something else, Belgium, we have the chance to have since 1984 continuous funding of research in Earth observation. The program is based on 3 pillars. The first one is for sure research. Then we are funding research, but we provide also research support with Bel-air site. It's a super site. I will give you more information about that. We support also sensors like Apex, for example. We have also a website, BOD. I will show you that also. What is nice also with this program is that we don't focus really on one thematic and one priority, but it's really wide. For example, at terrestrial level, you can submit projects on agriculture. It's important for you. But also about urban area, coastal area, water areas, ice, deserts, forest. Then it's really diverse. And you see also that we have a focus on interaction between land cover and climate change, really hot topic, epidemiology, and also security and risk management. Now, probably more interesting for you, I will give you some example of projects that we are funding in the frame of our national program. The first one is Belgium. The goal of this project is to combine information provided by satellite and Sentinel-2, for example, and also data, in situ data and data provided by the farmers, to combine everything and to provide to the farmers information at parcel level about different aspects, for example, the biomass level and evolution during time, nitrogen content, and so on. It's really important for farmers. And if you have more information about this project, you've got the website, and the coordinator is Pierre de Fourny, then it's not too far. Another example is Hypertemp. Here we are dealing with fruit orchards, and the goal is to develop geometric and radiometric correction of data acquired by drones, UAV. Then you have different acquisition, and with the pre-processing and processing of the data, you can have fusion of different data set, and you can follow the evolution of the plants and of the fruits. Third example, IFAT. Here, in this project, the researchers develop, test, and validate 7 indices to estimate the yield loss after weather problems, for example, or pest diseases or other aspects. And the goal here is for really small parcels and small farms to be able to provide insurance company with an estimation of the yield loss. The test site, the picture here is Senegal as example, but the idea was to extend this research in other countries. Another project conducted here at UCL, but by another team, is the test the potential of hyperspectral and UEV data for soil and crop properties map. Then on the picture you can see that in a parcel you can estimate the soil organic carbon content, and you can see that a parcel is not homogeneous, but you have big differences, and it's also important for a farmer to have these informations. Another example, we go to Spain for this one. Then this small insect is a weevil. The problem with these insects is that they are putting their eggs inside the trunk of the palm trees, and there the larvae are eating all the nutrients coming from the roots. That means that after one season, the tree is dead. And the goal of this project with very high resolution and data is to early detect this disease, to be able to manage and to work on the trees to protect them. In this project, the partners are also using deep learning technique for individual tree delineation, as you can see in nurseries of trees. Bitfen, again, project dealing with agriculture. Here we've got a company producing beet plants, and the goal is also here to early detect powdery mildew, which is a disease really common in our region. And usually this detection is done by visual detection. That means that you have to send every day, every 2 days, people on the field and to try to detect problem on the plants. But with UAV acquisition, you could be really fast and really cheap. again, an example of a project conducted by a team here in Louvain-la-Neuve. We are working this time with radar data, and the team managed to develop a radar sensor and a big antenna that you can mount on an UAV to follow the water and the soil moisture in the plantation. Again, important information for the farmers. And we already mentioned a little bit the potatoes in the previous presentation, but in Belgium, production of potatoes it's a religion. Then it's really, really important. And that's why we have also a project working on the early estimation of yields, production of potatoes, because it's at this moment that the farmers are negotiating their price with the traders. Then it's important that you know what will be the yield to be able to correctly negotiate your price. That was for the project. Now we have an initiative called Bel-air. It's a super test site in Belgium, where we, every 2 years, acquire satellite data, hyperspectral data with Apex I mentioned earlier, UAV data and in situ data collected by researchers. And all these data are put it on a website. We have now 4 test sites. On the north part, we are along the coast, and it's a coastal test site. In the middle, it's Brussels, then it's more urban test site. A little bit on south, it's here near Louvain-la-Neuve, it's an agricultural test site. And in the southeast part of the country, it's a test site focusing on forestry. The goal of this acquisition and of this data is for sure to strengthen research capabilities, also to provide data for researchers, and also to have data for calibration, validation of current or future missions. After 2 years, these data are available for everybody, then also from you coming from abroad. Then I invite you to visit this site. Oops. Another initiative, it's a BELSPO project. Then it's an airborne campaign organized over Belgium. It's a L-band full polarimetric and interferometric bistatic measurement over Belgium. The initial goal was to assess the potential of SAOCOM and SAOCOM CS satellites. SAOCOM is a satellite developed and launched by Argentina. And the original idea was at European level to have SAOCOM CS, a companion satellite. But finally, the project was not successful, that we had no money to conduct that. But we have seen that in Copernicus 2.0, for example, we have project to have also L-band satellite, and this project could be useful. And you see that an important application is agriculture. What is really original with this campaign is that you have 2 aircraft with sensor on board of the 2 aircraft, and one sensor is emitting and receiving, and the other is only receiving. Then you have 2 simultaneous images, one monostatic and one bistatic. Then it's really new and really interesting. Then the data are acquired over our test site I presently just before. And the data will be also available on the ESA website, then it could be also interesting for you. And while ESA is financing the data acquisition and processing, in Belgium we are financing a research team, and Pierre de Fourny is part of this research to work on this really innovative data. Now in Belgium we have a strong community of researchers working in Earth observation, and each year we organize what we call the Belgian Earth Observation Days. And that means that we have 120 people meeting and following presentation about stereo project and also networking, and it's really, really interesting. I show you vegetation, then 1 kilometer, low resolution. We discuss also about UAV, hyperspectral, but we would like also to give good access for our researcher to very high resolution data. And Pléiades is a French constellation of 2 satellites with a panchromatic resolution of 50 centimeter and multispectral resolution of 2 meter. But the problem with this very high resolution satellite is that the prices are really, really high. It's really expensive. But we negotiated with France an access for our researcher to this data. Espen present you all initiatives done by ESA to have access to the Copernicus data, the DIAS and so on. But in Belgium, we also developed our own collaborative grant segment to give access to Belgian researchers, but not only to Copernicus data, but also to data already processed. You have, for example, NDVI calculated on Sentinel data, FAPAR also, all really interesting data for research in agriculture. And for sure, the goal was not to make a copy-paste of the ESA initiative, but to go beyond. And then we have, for sure, Sentinel data, but we have also Apex, Vegetation, Probave, and all called Belgian sensor on this hub. And also it's also to give facilities and computers for high demanding calculation. To finish, I'm sure you are aware of the IGARS. It's a really, really big conference. Nearly 3,000 people are participating. It's really high level in terms of science. This year it was organized in Japan. Next year is in Hawaii. Then it's really far and really expensive. But in 2021 it will be here in Belgium. It's less far and less expensive for sure. And then with the Netherlands, we are organizing this conference. And then I already invite you to put in your agendas 12 to 16 of July 2021. We will for sure welcome you here in Belgium for this really big conference and to present all the research you will do in agriculture. That's all from my side. For more information, we have our website when you can find news, job opportunities, data access, and many more information. And I thank you for your attention.